Hello everyone. My name is Aditya. We are from Group 5 and we are going to give a project presentation demo on running clustering, association rule discovery and a decision tree using Weka and Orange software. So for this project implementation, we have gathered a data set uh, which is a PIMA Indian Diabetes Database. So we have gathered it from the Kaggle website. You can see here is the link to the website. So let me give you the context and the content. What does the dataset contain? Uh, First we will look at the context. So this dataset is originally from the National Institute of Diabetes and Digestive and Kidney Diseases. The objective of the dataset is to diagnostically predict whether or not a patient has diabetes based on the certain diagnostic conditions of the patient included in the dataset. So all the records in the dataset are or of the females of at least 21 years old of PEMA Indian heritage. So what does actually the dataset contain? So what are the columns in the dataset? So we have one target variable which is the outcome that we need to predict it. We need to predict the outcome whether the patient contains had the diabetes or not. So we have additional columns such as number of pregnancies the patient had and their BMI, insulin level, age, and so on. So let us have the all the attributes or see all the attributes in the data set. So the first one is the pregnancies, the number of times the patient had pregnancies. Second one is the glucose level, which is the plasma glucose concentration at 2 hours in oral glucose tolerance test. Which is the next one is the blood pressure, diabolistic blood pressure, which is measured in mm and Hg. The next one is skin thickness level, which is measured in mm as well. Insulin, which is a 2 hour serum insulin. And then BMI, which is body mass index. The next one is diabetes pedigree function. The next one is the age of the patient. The next one is the outcome, which is 0 or 1. 0 indicates the patient is healthy, 1 indicates that the patient is diabetic. So this is the target variable that we need to predict. So let us have a quick look into the data set. Here are the first 5 rows of the data set. In the first column, we have pregnancies. You can see the data is 6181. So these are the number of pregnancies that the patient had. The next one is the glucose level of the patient. So the next one is the blood pressure of the patient. The next one is the skin thickness. The next one is the insulin level of the patient. Then the next one is the BMI of the patient. And then the next one is diabetes pedigree function, and the next one is age, and then the final one is the predictor. Or we need to predict that is the target variable, which is the outcome. 0 and 1. We have only two values in that outcome and the outcome column, 0 and 1. So let us have a quick look into the what is the data types of the columns and how many normal values that does the data set contains. You can see here from like, we have total of 768 rows in our data set. So all of them are not having any null values, so we don't need to do any kind of imputations or removing of these null values. So the data set is already clean. So these are the we have data type for BMI and diabetes pedigree function is float, and all the remaining ones are of type integer. So the next one is, oh, let us see the distribution of the outcome of the outcome column or the variable. So we have only two values in that outcome column, 0 and 1. 0 is for healthy and 1 is for the diabetic patient. So out of 768, 65% of the data is 65% of the data is healthy, and then 35% of the data that is out of 768, we have 35% which are diabetic patients. So let us have the see at the number of unique values each column contains. So for pregnancies we have 17. For glucose column we have 136. For blood pressure we have 47. In skin thickness column we have 51 unique values. In insulin column we have 186. In BMI column we have 248. In diabetes pedigree function we have 517. In age column we have 52. The outcome which is a predict we have to predict this variable, we have two values in the unique values. So that's it. uh, the next person will continue with the next topic.
Hey all, I am Mahalakshmi and I am here to present on the topic Introduction to Veka and Orange Software. Veka. Veka stands for Waikato Environment for Knowledge Analysis. It is initially developed in the University of Waikato, New Zealand, and Veka is actually an open source software which provides tools for data preprocessing, and it also provides various visualization tools through which you can develop machine learning techniques, and those techniques can be applied to real world data mining problems. Veka is a collection of machine learning algorithms for performing data mining tasks. The algorithms can either be directly applied to the dataset, or we can also use Java code to apply those algorithms. Veka contains tools for data preprocessing, classification, regression, clustering, association rules, and visualization. Veka offers a wide variety of features for data preprocessing. So through this chat, we can see that various features which are given by Veka for data preprocessing techniques. So initially, the big data which we have, the raw data is which we have from the organizations contains various missing values, null values, and noise. So those data will not be used for applying machine learning algorithms. In order to apply machine learning algorithms, the data should be pre-processed. So Veka can be used for pre-processing the data. So initially, we will be giving raw data as an input to the Veka software. And first, we will start with the raw data collected from the field. This raw data contains various null values and irrelevant fields. And then Veka cleanses the data, and then the pre-processed data will be an output. So there are many features which are available in Veka, such as classify, cluster, associate, and attribute selection. In each feature, there are different machine learning algorithms. For example, in classify feature, we have linear regression, logistic regression, support vector machines, etc. And in clustering, we have simple k-means and filtered cluster, etc. And in associate, we have a priori. And in attribute selections, we have principal components. So all these algorithms can be applied on the data set. And Veka also provides visualization, like the various models can be applied on the same data set, and we can compare the outputs of different models and select the best that meets your purpose. And finally, the process data will be the output. And coming to the Orange software, Orange is similar to the Veka software. It also provides data mining tools. So Orange is a open source data visualization, machine learning, and data mining toolkit. It provides various programming front end for explorative, rapid, qualitative data analysis and interactive data visualization. Orange is a component-based visual programming software package. This is mostly used for data visualization and machine learning algorithms. So Orange components are also called as widgets. There are various kinds of widgets which are available in Orange. And Orange widgets for data, these are the different types of widgets which are available in Orange. So the widgets which come under data are input, data filtering, sampling, imputation, feature manipulation, and feature selection. The next one is visualize. And in visualization, we have various widgets like histograms, scatter plot, etc. And in classify, we have features such as machine learning algorithms. And in regression, we have features such as supervised machine learning algorithms. And evaluate also contains features such as cross validation, sampling based procedures, etc. And unsupervised is a widget which contains features such as unsupervised learning algorithms like k-means, hierarchical clustering, multidimensional scaling, principal component analysis, etc. So this is all about Veka and Orange. And thank you.
Hi everyone, my name is Yuehan from Profile. Today I will introduce how to use Weka to build the decision tree, clustering mode, and the association rules. So first, we need to load the data. So click Explorer, click Open File, find the location of your data. And one thing you should be careful about is the type of the data file. If you cannot find the data file, you should check the type. So this files of type. And choose the right type will solve this problem. So we use the CSV data file. So choose the CSV data, and so we can choose our file now. And here is some summary of each attribute. Okay, so next, let's build the decision tree. Click classify and click choose the trees. Let's choose REP tree. Also, we can choose the attribute whatever you want. So in this case, we choose outcome. Click start. Here is our result, but it's not a visualized tree. So we need right click the results and choose a visualized tree. So here is our visualized tree. Next, let's build clustering. So click cluster and choose. Let's try the hierarchical cluster first. So click start, wait for the system running, and right click visualize tree. So it's really hard to read, mess up. Maybe it will work better in orange, so we don't use this hierarchical cluster this time. So let's change it to simple k-mean. Start and choose visualize cluster assignments. So it's better. It's better to read. And also you can choose X and Y. For example, glucose, blood pressure, skin, BMI is better. It's easier to read. Okay, next, let's try to build associated rules. And one thing need attention is we should convert the attributes to nominal first. So let's see. We can see this each attribute, the type of each attribute are normical. So when we choose the associate, it's great. We can't do it. So we should convert them to normal first. So first we click or you just click the attribute you want to convert. Next, click choose filter unsupervised attribute and find normical to normal. Okay, choose this and click apply. Okay, so here we go. Some attributes are not good for the associate rule, so just ignore it. And so now we can do it. Just click start, and gets a result. The last thing I want to say is how to save and load the data, the mode. So just right click the mode you want to save, click save mode, and just tree, click save. Or if you want to load the mode, just right click the load mode and click tree mode. So here we go. It's the same. And you don't need to you don't need to put the same file, same data set as a load mode. You can just choose whatever you want, the data, any data, and then load the mode. The mode only will be the mode which you save. It doesn't matter which data you use. Okay, so that's all. Thank you. If you have any questions, please contact me. Thank you.
Hello, my name is Ali Majidian. Today I'm going to present utilizing Orange software to build the project model. For this project, we're using the beauties CSV file that we got it from Kaggle website. For the first step, you're going to import the data. So we go back to our uh, Orange software, and in the data section, you'll click on files. In order to get the data and also import it, we're going to double click on the file. And we see here in the file section, the BDs have been selected. Here we can see all the attributes. And the outcome here in the role section, we have specified the outcome actually as target. For the next step, we are going to build decision trees. This involves connecting the files to the tree section and also the tree viewer to see and view the actual tree model. We don't have to add the data table and connect it to the file. So here we are going to the model section and tree. We're going to connect it, and the visualize section here, tree viewer. By connecting all of it together, actually when we connect the tree viewer file, the tree model has already been built, and the tree viewer, if we click on it, we'll see the actual tree model, the visualization. And for the next step, we are going to build the hierarchical clustering. This involves distances and hierarchical clustering from unsupervised section, and also the scatter plot, which will get us the visualization for hierarchical clustering. So if we go back to the Orange software, we are going to the unsupervised section. We get the distances here, and we will connect it to the files here. And also we are going to get hierarchical clustering and connect it to the distances here. If we click on the hierarchical clustering, we will see different ranges. We can select them. If you can see here, the blue part, the blue section has been specified. And if we go back to the visualization section, we can add the scatter plot over here and connect it to hierarchical cluster. if we click on the scatter plot, we can see the scatter plot has been created based on the range specified in hierarchical clustering, and we can actually define the axis X or axis Y and select different attributes and get the answer to our questions based on different options that's being provided here. And here you can see the screenshots for building hierarchical clustering and scatter plots. For the last part, you're going to build and find actually the association rules. You have to define the file again and select the association rules from the software. So here we are going to go to the data section, files, and the file has been predefined. We have the diabetes CSV file, and in unsupervised, not unsupervised, and associate section, we'll define association rules, and we will connect these two together. If we double click on it, we have association rules options that we can define a specific rules for it, and then after we're finished we can click on find rules. It will take between 10 to 20 seconds, and we will have our association rules. Here you can see the list, and actually not the list, the data frame and the table for association rules. And when we are done with all of it, we're saving the whole file and the things that we've done. We will save it as a file. We'll define a file name now. Actually, we're going to save it in the location that we have in mind. And that's it for the presentation today. Hope you enjoyed it. Thank you so much.
Hello there, my name is Sriram Kollu. I'm from Group 5, and our project is Backend Orange software on clustering, association, rule discovery, and decision tree. And today I'm going to discuss about evaluation on clustering results on Weka software. So before going into that, I'll just give a brief description about clustering and k-means algorithm because that's what I'm going to discuss in front. So cluster analysis. So clustering algorithms are unsupervised algorithms used to create groups of data with similar characteristics. It aggregates objects with similarities into groups and subgroups, leading to the partitioning of datasets. Cluster analysis is a process of partitioning of datasets into subsets. These subsets are called clusters, and the set of clusters is called clustering. So the cluster analysis is used in many applications such as image recognition, pattern recognition, web search, and security. In business intelligence, such as a grouping of customers with similar likings. And when coming to the k-means clustering, k-means clustering is the simplest clustering algorithm. In the k-clustering algorithm, the dataset is partitioned to k clusters. An objective function is used to find the quality of partition so that similar objects are in one cluster and dissimilar objects in other. In this method, the center of cluster is found to represent the cluster. Center is taken as center of cluster, which is calculated as a mean value of point within the cluster. Now, the quality of clustering is found by measuring the Euclidean distance between point and center. This distance should be the maximum. And now we'll go into the k-means clustering implementation using Weka. So for that, we need to go into Explorer, and we just need to use our database .arff file, which is our Pima Indian database here. But we have already implemented that, so I'm just trying to load that model directly and just cluster that thing. So now I'll be loading that model here. from my system. So I just loaded it. As you can see here, the number of iterations are 4, and this is our sum of square errors, which is 149.5 something. And we have 2 clusters here, which has a full data of 768 and 568 as 2 clusters, and we have total of 9 attributes here. And I'm just going to start this model. So as you can see here, our Pima Indian database here, Pima diabetes set has got 760 instances with 9 attributes. And now we are just examining the output, right? So this is the mean value and this is standard deviation value of all the attributes. And this is the time taken to build this model, the full training data. And this is a cluster instances, which got split into 30, 26, and 44. And the lesser the instance, the more we ignore that instance. So these regarding the simple k-means clustering implementation. That's what we discussed in Veka software. And as I already mentioned here, we have used diabetes.arf as our data set in this. And we have got this square error of 149.51. And we have number of iterations as 4 and 9 attributes. And as I already said, these are the center of each cluster shown in the result window. So this is the mean and the standard deviation. We are considering this for these attributes. So as I already said, when there are very few instances, it is very difficult to make a meaningful decision. And now while coming to visualizing the clusters. So to visualize the cluster, we just need to press right click here, and we just need to view cluster segments, and we just need to select y-axis as cluster, and we can just see how data is getting visualized here, which are clustered here. So this is how we can visualize the data. As I already said, you can play around by changing the x and axis to analyze the results actually. So you can even jitter here, and the operations in Bayesian plot are similar to the one you studied in the class of classification. So while coming to applying the hierarchical cluster. So hierarchical cluster is nothing like we can just choose a cluster here, as we earlier selected EM as our cluster. Now we are selecting hierarchical cluster, and we can just start here. Now we can see the hierarchical cluster for both the clusters. Here it got 2 cluster instances, and this is my evaluation on clustering results. Thank you.
Hello, my name is Pratik, and I'm pursuing my master's in computer science at UNCC. And I'm here for my project presentation of KDD, and I belong to group 5. The topic given to us was Veka and Orange software to run clustering association and association rules and decision tree. And in this, I am majorly using clustering. I'm concentrating on clustering using Orange. So moving ahead, the data set we used in this was Pima Indian's diabetes data set, and which was taken from Kaggle, and the link for the data set is provided if needed. And the data set was originally from the National Institute of Diabetes and Digestive and Kidney Diseases. And they were considered multiple attributes where, like for calculating the for different diseases, and mainly diagnosing of diabetes. And consider and for in this database, every patient is at least 21 years old female. So these are the main audience targeted in this database. Moving ahead, what is clustering? Clustering is an unsupervised machine learning algorithm that identify similar groups in the data and groups them according to their similarities. Um, and it's marked in data points. So in this, for this demonstration, I've mainly used k-means clustering. So in k-means clustering, the data is divided into k clusters in a way that they have the one particular cluster has a centroid, and the distance between the centroid and the point is calculated, and the closest and the closest the data point is clustered to the closest centroid. Moving ahead, the working of k-means clustering, like I said, like it randomly selects a group of centroids, and then from then it iterates repeatedly to get the positions and the distance between the different data points to the centroid. And when there is no change in the value, the centroid is the centroid is stabilized, and a defined number of iterations are formed. And to demonstrate this k-means clustering, I'm using the Orange software. The Orange software is an open source data visualization, machine learning, and data mining software, where it's used for visualizing programs and for front-end exploration of data and data visualization. And I'll demonstrate to you the working of this. And first, I'm going to import the data set. That's the diabetes data set from. Yeah, I'm going to import the data set. Once the data set is loaded, we're going to use the k-means clustering here. So I use this right here. And implement k-means clustering with the data. And finally, I'm going to visualize it using a scatter plot. So the k-means clustering is scattered using, is plotted using a scatter plot. If I click on this, I get a scatter plot. And and this so that these three centroids here, or three clusters here, and they're indicated with the blue circles, or the red cross marks, or the green triangles. And this the three clusters that are represented here, and you can access each of the data like by clicking on by keeping the cursor on the data point. So this is by keeping and gives it shows you which cluster it belongs to, and the different the different data under which data points is there. And the Orange software automatically chooses the X and the Y axis, which forms a better clustering algorithm. So for the k-means algorithm, using the age and the insulin level was forming a better cluster. So that's the reason it took it automatically. And if we had used any other clustering algorithm, it would have taken a different different x-axis and a y-axis. So yeah. Moving ahead. So yeah, this like we saw in the demonstration, this was the visualization output where I've taken the CSS file, then imported it into a k-means algorithm, and then we visualize the data using a scatter plot. And yeah, this was the scatter plot that we just saw on the present on the demo. And yeah, I think this concludes my presentation. Feel free to get in touch if you have any questions regarding it. Thank you.
I'm from Private Group 5. Today I'm going to tell you about the association rules discovery Weka. So what are the association rules? So accordingly, association rules are like studies which are to be maintained and try to uncover the rules which are to be hidden with the data sets. So mainly association rules are like used for the good results for the categorical data, and also mainly it allows to mine the frequent item sets in order to generate the main association between them. So and also association rule is also like being applied from 1 to items, and also it's for understanding the item set, the given transaction of proposition in a wide range of bioinformatics disease, and it's all used for like web mining and also text mining. And coming to what is Weka and why. So Weka is like representing the Wekato environment for knowledge analysis. It is mainly used for multiple built-in functions and to implement a wide range of machine learning, and also used for the linear regression to the neural networks. So Weka is for the collection of machine learning algorithms for data mining tasks. So that algorithms that can be either to be applied or like directly for the data sets to be maintained by the tools of like data preprocessing, classification, clustering, and also visualization. So usually Weka can be preprocessed classically and grouped and also being viewed. So there are some different formats like ARP, FF, CSV, and also JSON. So next. So what is Weka interface? So this is the interface which we have like type of applications like Explorer, Experimenter, and also Knowledge Flow, and also Workbench, and also Simple Sales Tray. So we have chosen this in some of the website which are designed. So what is and this is the loading dataset in Weka. So here we have used PM diabetes dataset. You can see the graph which is below, and also we have here like process at the next stage which we know the project. Moreover, also we have used software and the latest version for the system to design this, and also we have converted this error format so that we can read this into like Weka interface. So and also we have working and also analyzing the data sets using the Weka GUI. So, and we have seen this for the more data mining in the Weka. We have, and also we have advanced features using the software as we discussed. So it builds an experience from like previous, and also it's like a pre-rich site. So association rules for the given data sets. So you can see here these are the association rules which we have executed, and this is output. And also we 1 second. So here we have the efficiency of levelized for the frequent item sets, so which is like to be reducing the search space. So, and we have like also test frequent item set for the infrequent, which is separates supersets with the infrequent. So when we are like creating a table containing support count, we can represent item presence data set, which is like A1. So comparing all the comparing all the set items, we used to count the minimum support, and also we used to count candidate sets to be removed by those items. And here we have required classifiers like A1, A2, A3, A4, A5, A6, A7, A9, which are to be maintained by the minimum support. So these are to be filtered using the association rules. And others rule addition minimum support. So it is a level which is to be maintained by the whole informational collection covered by the whole rule, and to be maintained by the precursor and the subsequent. So what is like insignificant confidence? So it is the type of proportional of the quantity of models which fit for the left side precursor. So the most extreme number of rules are to be limit of the quality rules, and the calculation produces such a large number of rules can dial back the gadget essentially. So these are some of the association rules to be maintained. Yeah, thank you.
Good morning, everyone. My name is Pranav, and I'll be presenting about the association rules discovery in Orange. So first, let me talk about the introduction. So what exactly are the association rules? So association analysis studies are that try to uncover if-else rules hidden within the dataset. It usually yields good results with categorical data. The most common example on association analysis is basket analysis. I'll be talking about this in a line in the next slide. In addition, it has a wide range of uses such as bioinformatics, disease diagnosis, web mining, and text mining. Our project was on disease diagnosis. Next, what is basket analysis? So in basket analysis, we keep products bought by shoppers in a list and wonder which products are sold more together. So as the term implies, basket. So we take all the stuffs that a shopper buys and puts it into a basket and analyze what is being bought more. Next, here shown below is the association rule window in orange from our project. On the left hand side, we have a certain information and different types of rules and filters, which I will be talking about in the next slide. Rule indicators. On the left hand picture on the bottom, we have minimum support, minimum confidence, and maximum rules. So the minimal support It is the percentage of the entire data set covered by an entire rule, which is antecedent and consequent. Next is the minimal confidence, which is set to 70%. So it is the proportion of the number of examples which fit the left side, which is the antecedents. Next is the maximum rules, which is set to 20k. So maximum number of rules is the limit of the number of rules the algorithm generates. Too many rules can slow down the widget considerably. And here we also have two different types, which are induce only classification rules and restrict search by below filters. So let me talk about the two more things, which is antecedents and consequence. So antecedents here, where there is filter by antecedents, it has contains, minimum items and maximum items. So what does the contains block have? So it will filter the rules by matching space separated regular expressions in antecedent items. The maximum items, it is the minimum items. It is the minimum number of items that have to appear in an antecedent. Maximum items, it is the maximum number of items that can appear in an antecedent. Next, what is a consequent? Here we have another block saying filter by consequent, which has again contains items minimum and maximum. Contains. So this filter rules by matching space separated regular expression in consequent items. Minimum terms. The minimum number of terms that have to appear in a consequent. They have to appear in a consequent. And the maximum terms is the maximum number of terms that can appear in a consequent. Thank you.
Hi everyone, I'm Tejasvi and I'll be presenting about decision trees using Vecka. A brief understanding of decision trees is important to understand how it works in the Vecka interface. So decision trees are also called classification or regression trees. They work by learning answers to a hierarchy of questions if or if not that leads to a decision. The output is a tree-like structure. For example, if we want to predict a person if he orders a food or not, the output tree can be as follows. The first question would be if the person is hungry. If yes, did he get a lunch or not will be the next question. If yes, then no order. If no, then is it month end or not? If it is a month end, no order. If it is not a month end, then order. For the first question itself, if it is a no, if the person is not hungry, then he'll not order anything. This is how a decision tree works. Each node in the tree represents a question derived from the characteristics present in the dataset. The dataset is divided based on the questions until the maximum depth of the tree is reached. The last node represents to which class the value belongs to, and the top node is the root node and the last node is called leaf node. A node divided into subnodes is called parent node and the subnodes are called secondary nodes. These are the important terminology which is to be known in a decision tree. What is Vecka and why do we have to use Vecka? Vecka represents Veckato environment for knowledge analysis. It has multiple built-in functions to implement a wide range of machine learning algorithms from linear regression to neural networks. With Vecka, data can be pre-processed, classified, grouped, and also can be viewed. It supports different file formats like ARFF, CSV, C4.5, and JSON. So any person who does not know how to code can implement all the machine learning algorithms using Vecka platform. This is how a Vecka interface looks like. We use the Explorer tab to get the dataset into the Vecka software and then work on it for different machine learning algorithms. We use diabetes dataset to implement decision trees on Vecka platform. So when we use the Explorer button shown in the previous slide and import the dataset which we have into the Vecka platform, this is how the interface looks like. So it classifies and analyzes the dataset and then produces the graphs which are present here. So when we click on visualize all, we get all the graphs produced from our dataset, and that will be shown in the next slide. So this is how all the graphs present in our dataset looks like. So the attributes which we have in our dataset are pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes, pedigree function, age, and outcome. So these are all the symptoms or cases that is taken into consideration for diabetes, and then this is the dataset on which decision tree classifier is used to produce the outcome. After importing the dataset into the Weka platform, we go to classify tab, and then we get to choose a rep tree in it. So the rep tree is reduced error pruning tree. So this is a quick decision tree learner that builds a decision tree or regression using information gain as a division criterion. So after choosing it, we just click on start, and this builds the decision tree classifier. This is how the output looks like for the diabetes dataset. For visualizing the decision tree, we right click on the results list and then click on visualize the decision tree. This is how the decision tree for diabetes looks like. Thank you. This is all about decision tree using Weka platform.
Hi everyone, I'm Naveen Kola from Project Team Fire. Today I'm going to present you my group's project, Veka on Orange software, run cluster. By using them, we have to run clustering, association, rules discovery, and a decision tree. So today I'm going to tell you about decision trees and also um, how to get decision trees using Orange software. So what are decision trees? Decision trees are also called classification or regression trees. They work by learning answers to a hierarchy of questions. If not, that leads to a decision. The output is a tree-like structure. For example, if you want to predict a person will order food or not, the output tree is as follows. See, so first we get to know that if the person is hungry or not. If the person is hungry, he might buy lunch, he might order food. If he's not hungry, he's definitely not gonna order food. So if he's hungry, again we have like two situations. He's gonna directly order the food, or he might think about the money, like if it's a month end, or like if he has enough money in his bank account, all those things. So it depends on that situation. So if it's a month end, or if he has um, enough money in his bank account, if he has enough money in his bank account, he's gonna order the food if he feels he needs to eat it. But if he doesn't have money, probably he's not gonna order the food. So that's how decision trees work. Depending on the answers that you get in the root node, the children node's solution depends on the parent node. So next, so we'll see the things in decision trees. So in decision trees, each node in the tree represents a question derived from the characteristics present in your dataset. So every node represents a question in a decision tree. So after that, the dataset is divided based on the questions until the maximum depth of the tree is reached. That means the last node represents to which class the value belongs, and the top node is called the root node in a decision tree, and the last nodes are called leaf nodes. And a node divided into subnodes are called parent nodes, and the subnodes are called secondary nodes or children nodes. So we're gonna calculate decision trees using Orange software. So what is Orange software? So Orange is an open source data visualization, machine learning, and data mining toolkit. The objective of Orange is to provide a platform for experiment-based selection, predictive modeling, and recommended system. So Orange is a data mining software which is used for predictive modeling and data visualization and all those things. So this is the interface of the Orange. I'm going to show you how Orange works in a second. So this is how the Orange, how the packages in Orange works. See, and this is a scatter plot that I've plotted for the dataset Iris dataset in my execution of Orange software. So I'm going to show you how I did that in a second. And this is the decision tree. This is my the goal here is to find the decision tree. So this is the decision tree visualization in Orange software. So yeah, just a second. I'm gonna show you how Orange works. So first we input, we select a dataset, and then using that dataset, we classify the dataset using a tree structure, and then from the tree structure, we view the decision tree. This is the decision tree that I've got for the dataset Iris dataset, and then now I'm going to show you the scatter plot for the dataset. Yeah, it's here. So this is how Orange software works. Yeah, that's it, guys. Thank you. Thank you, everyone, for giving me this opportunity.